Today, I'm representing MSBA Financial Group, and I will be conducting data analysis and making predictions. So the platform I'll be using is AWS, Amazon Web Service, and it's this online platform that hosts many cloud computing services. And these are the four data sets I'll be using: the financials CSV, counting ratios CSV, bankruptcy text, and this unlabeled CSV, which we'll be using later to make predictions on. And this is what my data pipeline looks like. It's how we convert data into a model that makes predictions. And right now, we're at the starting step of data lake, which we call AWS S3. And you can think of S3 as this data repository where we can create these buckets to store data. In my bucket, I've created two folders, data files and prediction. In data files, I have my first three data sets, which I'll be consolidating to form one unified table. And in my prediction folder, I have my unlabeled CSV, which we'll be using to make predictions later. For our next step, we're going to move on to AWS Glue, where we'll perform ETL, which stands for Extract, Transform, and Load Data. And AWS Glue is this interface where we can input commands to modify data. In my case, I've joined the financial and ratio CSVs into one table, then exported it to Amazon Redshift, which is the next step, the data warehouse. And in Amazon Redshift, we can create these clusters where we can run queries for data. This makes it so that data can be more easily manipulated and can also be pulled for later other uses, such as creating a model, which is our last step. And to create a model, we're going to be using SageMaker Canvas. And what we do is we feed it our consolidated data set, and this is the model it creates for us. So as we can see, model predicts bankruptcy stats with a 97% accuracy figure, which is very high. And on the right, if the model predicts that a company will not go bankrupt, it's correct 99% of the time. So it's a very accurate model. And here are some interesting findings about my model. As we can see on the left, the top three highest contributors to model success are persistent EPS, borrowing dependency, and net income to total assets. And persistent EPS is the highest at 14%. That means 14% of the model success can be largely attributed to persistent EPS. So that means it's really influential. And my other finding is I created this scatter plot to demonstrate the relationship between persistent EPS on the horizontal bar and borrowing dependency, which is the second highest contributor. And as we can see, persistent EPS is a lot more variable. It's for the 600 entries, it's a lot more variable. And borrowing dependency mostly stayed constant across companies. So what that could possibly mean is borrowing dependency isn't as significant as persistent EPS in predicting bankruptcy rates. For our last step, we're going to feed our unlabeled CSV into the model to generate bankruptcy predictions for 10 companies. And based on these results, I have several recommendations to make. My first investment recommendation is Pharmasolv because it has the second highest non-bankruptcy rate at 98.65%. It has the highest persistent EPS at 0.225 and the highest ROA before interest percent after tax. So what this means is it's more effective at generating profit based on its assets and its shares. My second recommendation is NineTech. It has the highest non-bankruptcy rate at 99%, so it's very safe. It has the highest net worth to assets ratio by a mile, so that indicates financial and general company stability. And it also has the second highest working capital to equity rate. So this could be appealing to potential investors.